Welcome back, everybody. This is our seventh session in JEE Mains previous year questions for chapter Wave Optics of class 12th. Before this video, we have made several videos, actually 6 videos in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous years, so if some of your friends are preparing for NEET, then they can also watch those videos. If you find this content useful, helpful, then do press the like button, share it, and subscribe to our channel. Also, if you like to support us financially, you can scan any of the QR code in front of your screen and also available on the each slide and donate us with whatever amount you want. Any amount will be highly appreciated. With this, let's start today's video. In the previous one, we covered up to around 70 or something. I think, yeah, this was the last one of the last. Yes. So we will going to start with 73 today. So here a ray of light is incident from denser to rarer medium. The critical angle for total internal reflection is theta IC and Brewster angle is theta IB, such that theta IC by theta IB is neta is 1.28. Relative refractive index of the two media is. So here we have to find out relative refractive index, and we can say that relative refractive index is going to be mu r. So from that we can write that theta of c or sine of theta c will be equal to 1 by mu r, and we have to calculate mu r. We will calculate mu r, and let us also define mu r. Mu r will be refractive index of the denser medium by the refractive index of the rarer medium. Now, as we know that for denser medium, refractive index is always greater than the rarer medium, so this ratio will be greater than 1 by default. And if we can see that all of the answers are less than 1, means actually what we have to calculate, we have to calculate 1 by r, 1 by mu r. Okay, let us make a correction that here we are using mu r twice, so let us mark that we have to calculate 1 by mu. Sorry, we have to calculate mu. So let us, our relative refractive index is mu, and then sine of theta c will be 1 by mu, and mu is mu denser by mu rarer, and that will be greater than 1, and all of our answers are less than 1, so actually we have to calculate 1 by mu. That will be the relative refractive index of the rarer with respect to denser. So first we will calculate mu, and then we will find out 1 by mu. So starting with this, we know that tangent of IB will be equal to mu. That's the relation for a Brewster angle, and here 1 by mu is equal to sine of theta c. So from this, tangent of IB is equal to 1 by sine of theta c. Now we have been given another relation, that neta, that is 1.28, and that is equal to sine of theta IC divided by sine of theta IB. Now what we can do, now we can write this term like this. We have mu is equal to tangent of IB, that can be written as sine of IB divided by cos of IB. Now let us multiply it by sine of theta c divided by sine of theta c. So we multiplied it by sine of theta c and we divided it by sine of theta c. Now sine of theta c by sine of IB. So we can say this term, sine of IB by sine of theta c. This will be equal to 1 by neta, or we can say 1 by 1.8. So from this, mu is equal to sine of theta c by cos of IB into 1 by neta, that is 1.28. Now this sine of theta c from this will give us 1 by mu. So this can be written as further that mu is equal to 1 by mu cos of IB into 1.128. So this will become mu square is equal to 1 by cos of IB into 1.28. Now the only thing left to calculate is cos of IB. Now for that we can again use tangent of IB, and for that we will use Pythagoras theorem. We know that tangent of theta, or here tangent of, suppose this is angle IB, is equal to mu. So this will be perpendicular will be mu and base will be 1. So this side will be mu square plus 1, and from this we can calculate that cos of IB will be equal to 1 by under root 1 plus mu square. Now we will substitute this value in this relation. So we will have the relation that mu square into equals to under root 1 plus mu square into 1.28. Now from this, if we square both of the sides, we will get mu raised to power 4 divided by under root 1 plus mu square is equal to 1.28. Now to solve this, we can make let us write mu square as x and mu raised to power 4 will be then x square. So this will be x square divided by 1 plus x is equal to 1.28, and this will become x square minus 1.28x minus 1.28 is equal to 0. So this is a quadratic equation in x, and when we solve it we will get one possible value of x, that is 1.4. Oh, sorry, not 1.4, that will be 1 point. Value of x will be 1.875, and value of mu will be mu from this will be under root of x, and that will be under root of 1.875, and that will be 1.4. So value of mu comes out to be 1.4, and the relative refractive index which we have to calculate, that will be 1 by 1.4, and that will be equal to 0.71, and the nearest match that we have to that is option C. So option C is going to be the right answer here. Now let us move to the next one. In the experiment of single slit diffraction pattern, first minima of the red light coincide with the first maxima of some other wavelength. If wavelength of the red light is 6600 angstrom, the wavelength of the first maxima will be. Now for diffraction, we know that path difference delta x is equal to a sin theta, and for maxima it will be n plus half into lambda, and for minima it will be n times lambda. So here we have first maxima, so we can say first maxima, that will be 1 plus half into lambda, and that is lambda for the red, that is 6600, is equal to first yes, that will be first maxima for some other wavelength. So first maxima, for that we will have relation this, and that will be 1 into lambda. So from this lambda will be 3 by 2 into 6600. Oh sorry, we made a mistake here, we need to correct it. That it is given that first maxima of some wavelength. So first maxima of some wavelength will be given by this relation. So that will be 1 plus half, and wavelength we have to calculate. So that will be lambda dash is equal to first minima of red. So first minima of red will be given by this relation. So that will be 1 into red wavelength, that is 6600, and from this lambda dash will be 6600 into 2 divided by 3, that will be 4400 angstrom. That is option B here. In the next one, beam of unpolarized light of intensity I node is passed through a polarized A and then through another polarized B, which is oriented so that principal axis make an angle 45 related to A, the intensity of emergent light. So suppose this is our polarizer A and this is our polarizer B. The angle between the axis of A and B is 45. So here we have unpolarized light coming towards A. So if intensity is I node, so we know that output of A will be I node by 2, and when it passes through B, then it will become I node by 2 into cos square of 45, and that will be I node by 4. So option C is right answer. In the next one, we have two statements. So out of radio waves and microwaves, the radio wave undergoes more diffraction. Radio waves have greater frequency compared to the microwave. So we know that radio waves are used for communication in the radio broadcasting like AM and FM stations, where a microwave are used for heating purposes. So that basic relation is that we can say energy of microwaves is greater than energy of radio waves, and uh, lambda or the wavelength have the inverse relation as for the energy. So here lambda for microwaves will be lesser than the lambda for radio waves, and frequency will have the same relation as for energy, that frequency of microwaves will be greater than the frequency of radio waves. So or statement 2 will be wrong here, that radio wave have greater frequency, and option 1 will be right, because for diffraction to occur, the slit width or the object size should be comparable to wavelength. So when radio waves travel in the free space on the earth, we can say in our environment, so it encounters buildings, it encounters trees, and for proper diffraction to happen, the size of the wavelength of this wave should be comparable to the size of these buildings, size of tree, and which is true in the real life. That's why these waves can easily bend around the buildings and can bend around the trees and can give us reception even inside the building, even below the tree, reception of the AM and FM signals. So statement 1 will be right and statement 2 will be wrong here. So yeah, that is option C. 1 is true, second is false. Here, a person lives in a high-rise building on the bank of a river 50-meter wide. Across the river is a well-lit tower of height 40-meter. When a person who is at height 10-meter looks through the polarizer at an appropriate angle, the light of the tower reflected from the river surface, he notes intensity of the light become from the distance x from his building is the least, and corresponding light coming from the light bulb at the height y on the tower. The value of x and y are close. So here we have to find out value of x and y. So what happens here, that at this point where person is collecting light, there is two ways to light to reach here. So suppose here is our light source and this distance is y. So one, this light can come after reflection, and second, that light can come direct. When this light is coming after reflection, so what can happen here, that light can strike at Brewster angle, and when it strikes at Brewster angle, it becomes polarized, plane polarized, and it loses some of its intensity. That's why when light is he is seeing the reflected light, so he will observe less intensity as compared to the direct light. So Basically, we will have triangles here, and law of reflection says that angle of incident, suppose this angle is theta, then this angle will also go to be theta. So if we make here, suppose this angle is phi, then this angle will also be phi. So from this, tangent of phi will be 10 by x from the left side triangle, and from the right side triangle we will have tangent of phi will be y divided by total length here is 50, so y by 50 minus x. So that is one relation. Now we have to find another relation in y also, and that can be calculated using Brewster angle. According to Brewster angle, mu is equal to tangent of incidence angle, that is tangent of theta, and here mu is 4 by 3. So 4 by 3 will be tangent of theta, and from the triangle here if you draw it, then this will look like something like this. This is the lower triangle with angle phi, and if we draw a upper triangle like this, then this angle will be theta. Here this will be x and this will be tan. So from this we can write tangent of theta is equal to x by 10. So x by 10 will be equal to 4 by 3, and from this x is 40 by 3. Now x is 40 by 3. Now if we substitute it here, so what we will get? We will get 10 divided 40 divided by 3 will be equal to y into 50 minus 40 by 3. So this will be uh, 3 by 4, and on this side we will get y by 150 minus 40, that is 110, and here we will have 3, so 3 get cancelled, and this will go on 55 and this will on 2. So y will be 55 by 2, and that is 27.5 meter. If it is in centimeter, then it will be in centimeter. So that is option B, I think. That is the nearest match. Also, x was 40 by 3. So 40 by 3 will be 13.33. So that is option B. So option B is the nearest possible match. Now let us move to the next one. The first diffraction minima due to single slit diffraction is seen at theta is equal to 30 degree for the light of wavelength 5000 angstrom falling perpendicularly on the slit. The width of the slit is. So for the diffraction, we have condition that A of sine theta is equal to n lambda, and here sine theta is sine of 30 will be half. So we can say A into half is equal to first minima, so 1 into 5000 into 10 raised to power minus 10. So from this A will be 10,000 into 10 raised to power minus 10. So that is basically 10 into 10 raised to power minus 5. Oh, sorry, 10 into 10 raised to power minus 6. And that can be written as here 10. I think none of the given option is matching proper. So it should be either 10 into 10 raised to power minus 7, or it should be 0.1 into 10 raised to power minus 5. But none of the given option is matching here. So I think there is some problem with the options. Now coming to the next one. Two polarites have their polarizing direction parallel to the intensity of transmitted light is maximum. The angle through which either of the polarized must be turned if the intensity to drop by 1/2. So initially both of RBs are parallel. So when these are parallel, so if incident intensity is I node, then after passing through the first polarizer it will be I node by 2, and after passing through the another polarizer it will be again I node by 2. 2 because both of these are parallel. Now we have to rotate them in such a way that this intensity changes to half, or we can say it becomes I naught by 4. So we can write I naught by 4 will be equal to I naught by 2, that is the incident intensity, and suppose there we have rotational, we have given rotation of angle theta. So I naught by 2 into cos square of theta. So this will be half, and cos of theta will be 1 by root 2. So theta will be either 45 or 9 plus 45, that is 135. That is option A. So option A will be the right answer here. Now in the next one, on viewing a clear blue portion of the sky through a calcite crystal, intensity of transmitted light varies as the crystal is rotated. Statement 2, light coming from the sky is polarized due to scattering of sunlight by the particles in the atmosphere. The scattering is largest for the blue light. So here both statements are true, that light coming from the sky is first of all scattered, and mostly blue color is scattered, and that is also polarized, and so its intensity will vary with rotation. So both are true, and second is correct explanation of the first. So option B is the right answer. In the next one, in the experiment, electrons are made to pass through a narrow slit of width d comparable to the de Broglie wavelength. They are detected on the screen at distance d from the slit. So here we can see that we have a single slit here. So what we will observe? We will observe a diffraction pattern, and that diffraction pattern, what we will have? We have a central maxima with very bright intensity. We know that for diffraction, intensity varies like this: I is equal to I naught sine of phi divided by phi square, and here phi is exact value of phi is pi b sine theta by lambda. Or normally for the first maxima we take it 3 pi by 2, then for the secondary we take it 5 pi by 2, and maximum intensity is carried in the central maxima. So option B and C does not show any type of diffraction behavior. In option A and D we have diffraction behavior, but in A the peak is slightly smaller as compared to option D. So option D will be the right answer, as central maxima carries the most of the intensity, around 97 to 98% intensity. So the option D will be the right answer. Now, if I naught is the intensity of principal maxima in a single slit diffraction, that one with the intensity when slit width is doubled. So here we have again a relation that I is equal to I naught sine of phi, or sine of beta by beta square, and here phi will be pi b sine theta by lambda. Now, as mentioned that here slit width is doubled. So as slit width is double means this b is double. So here the behavior will be, we can say, as we have sine phi by phi. So this behavior will be quite complex to analyze. But what we can do here, we can consider that extras with, initially this was the slit width b. Then this we have doubled it. So we consider it as a another slit of uh, another slit with width b. So from this we can consider like here we have two slits, each of giving intensity I. So this will be like interference, where if both of the slits are giving intensity I, then maximum intensity is 4 times I naught. So its initial intensity in case of diffraction was I naught, and now it becomes 4 I naught. So option A will be the right answer. Now, when an unpolarized light of intensity I naught is incident on a polarizing sheet, intensity of light which does not get transmitted is. So, when it strikes on the polarizing sheet, the part which is perpendicular to the polarizer's angle of polarization, it will not be transmitted, and that will be exactly half, because half is along its direction and half is perpendicular. So, option B will be the right answer. two points, two-point white dots are 1 mm apart on a black paper. They are viewed through pupil of diameter 3 mm approximately. What is the minimum distance at which both dots can be resolved by the eye? Take the wavelength of light as 500 nanometer. So for eye, that resolving angle will be equal to 1.22 lambda by diameter, and that should be equal to the x divided by the distance, because we can suppose this is our eye, this is the distance between the objects, and this is the distance of the object from the eye. So here angle theta will be x by r, and that is resolving power of the eye, that is 1.2 lambda by d. So that will be 1.22 510 raised to power minus 9 by diameter. Here that is 3 mm. So 3 into 10 raised to power minus 3 is equal to x, that is 1 mm apart. So 1 into 10 raised to power minus 3 divided by r. From this, when we solve for r, we will get 4.91 meter. That is comparable to the option B, that is given to as 5 meter. Now, in the next one, the angle of incidence which is reflected light is totally polarized from the reflection of air to glass. Refractive index is n. So, for that we know that we will use Brewster's angle, and that is equal to tangent of IP, and from this IP will be equal to tangent inverse of mu. So, that is option D. Yes, option D is the right answer. Now, moving to the next one. Wavelength of light used in optical instrument are lambda 1 and lambda 2, their ratio of resolving power. So, we know that resolving power is equal to D by 1.22 lambda. So, resolving power is inversely proportional to lambda. So, we can say resolving power of 1 by resolving power of 2 will be lambda 2 by lambda 1, and that will be 5000 by 4000. That will be basically 5 by 4. So, option D is right answer. So with this, we end this video here. Hopefully what we have covered is helpful to you. Again, if you have any doubts and or problems, you can put them in comment section. I would like to resolve them. And if you like this video, then do like it, subscribe to our channel, and if you like to donate or something, then you can scan this QR code. With this, thanks on watching, and we will meet in next video.